be talking about more on satellite data availability because when we started our work, we didn't know where are the satellite, which is the satellite available, what is the open source satellite, how we have to download all these things. So we had a problem in all such things. So we started looking for it, and we found there are a lot of data which is available, and we can use it for our analysis. So coming to main question, then what is an image? So it's not a satellite image. If we can say what is an image, so what it is? What is an image? Huh? Okay, that is a digital image. Yeah. So it's a visual representation of something. Anything, it can be anything. So then coming to digital image, here it is a group of pixel. So you know that, and sources can be anything like satellite, mobile, UAV. There are so many sources of digital images. So our topic is on satellite imagery, so I'll talk more on satellite imagery availability. So satellite imagery, we have a lot of government and commercial satellites right now available. So if we have to speak on satellites in world, how many it is available? If I have seen this in one blog. They are telling that there are 4,987 satellites which revolve around our Earth in 2019. So in 2020, it will be 2020. It will be more, still more. So this is just a statistics. And to start with our remote sensing, we have this electromagnetic spectrum, and if we can see, so for our remote sensing and application, we will use only these things: visible light, infrared radiation, and microwave thing. So these are the open source satellite data available. So we have Landsat. So when we talk about Landsat, there are like Landsat 1, 2, 3, 4, 5 Landsat data is available. Right now, operational is 7 and 8. So we are downloading data from 8, Landsat 8. So it has a resolution of 30 meters and up to 60 meters. So, and next is MODIS. So it is nearly daily data, MODIS, but it has 36 bands, but resolution is very coarser. And Sentinel, we have Sentinel 1, 2, 3, 4, 5, 6. So 4, 5, 6 is yet to launch, and it is planned to launch. It is mainly on atmospheric observation, then sea level measurement, those things. So for remote sensing satellites, we are using Sentinel 1 and 2. So 1 is for the SAR data, microwave remote sensing, and Sentinel 2 is for multispectral data. Coming to Aster, we have Terra and Aqua. There are two satellite things which it is acquired, and it is having resolution ranging between 15 to 90 meters. So this is a table which shows what is its resolution, swath, and radiometric resolution, temporal resolution, where it is applicable, and availability from which date, which year, and what is the coverage of that satellite. So we have Sentinel-2, which is 10 meter. So this is the highest resolution satellite right now, which is available for open source. So 10 meter data, which is having around 13 bands. So and for the vegetative index and other things which related to vegetation, we use band 2, 3, 4, and 8. So these are the 10 meter high resolution satellite image. And we have Sentinel-1 data, which is 1A and 1B, which is having a 6-day, combining 1A and 1B, it is a 6-day temporal resolution, and it is from European Space Agency. All others are like NASA, Japan, NASA only, it is related to that. But Sentinel is related to European thing. And Landsat, we have 30 meter data, and 15 meter, which is a PAN, and 30 meter data is available. With the 9 bands, here we have thermal bands. Landsat, we have thermal bands, which is not found in Sentinel. And we have Modi's data for Terra and Aqua, which is nearly daily data cadence. It is like 1 to 2 days it will cover entire world, but the swath is very high. And we have Aster data, which is having 15 bands. So it is mainly for land surface temperature, reflectivity, and elevation things. So these are some commercial satellites which are available: GeoEye, Digital Globe, then Airbus. So these are some of its parameters which we have found out. So here we have Cartosat. We are using in our analysis. We are using Resource-Sat 2, then Cartosat 1 we have used as a base map, and we have planet data, which is having 3-meter resolution, and it has 4-band data, which is near infrared is there, and it is available for day-wise data, entire world. Day-wise data it is available. So anybody can, when it is a subscription basis, we had a opportunity to download this data for our South Odisha region and do analysis over it. And it is like you can see that some of the Balakot thing and all, they did analysis on this planet data, high resolution. They have more high resolution data with SkyMet or something like that available with the planet. So RapidEye, PlanetScope, and SkyMet, they have more high resolution data. So this one I found in one blog with this nice representation of how do you want to do, what do you want to do with the data. Whether you want, yeah.
4-band, what band, what it means?
Sir?
You written one over there. 4-band.
4-band, it is multispectral. One is panchromatic data. Panchromatic data. And this is like a representation of how you want to go with the satellite data. So it is whether if you are willing to pay money like that, so it is there. And this information, this GIS, geography, Earth, here we have satellite data of top 50 satellites which is available, and you can have information about it. So this is our total number of images for our project area. It is around 109 images. We have Sentinel-2, Sentinel-1, Landsat. Then Planet we had for last year, previous year, 2018, February and March, and Cartosat we have. So for the downloading of data, we have Ski Hub Copernicus. That is a official website for Sentinel download. So for manual download, if you have to do, you have to open browser, then you have to log in, then AOI you have to give, all these things are there. You have an automated system where you can write a Python code and you can download it with a task scheduler. We have scheduled it, so it is automatically downloaded and it is doing. So you can have this API reference here, Sentinel SAT. So this is how we imported and did for our area. So coming to advanced image analytics, so we had many classes regarding advanced image analytics earlier also. So when we talk about machine learning, main things are like supervised and unsupervised classification. So in supervised, we have classification, regression, and assembling. So then classification and unsupervised, it is association, then clustering, and dimensionality reduction. So these are the main things we have in a machine learning. So when we come to supervised learning, here we know the correct labels are already given to the system or the algorithm which is already working, and we classify the data. So the training data set is already given to it. So classification, it is like a categorical variable. And for regression, if you have to take it as a continuous variable. So in classification, we have this SVM, which we use for object-based classification. So they are object-based and pixel-based classification. And SVM is object-based classification, and maximum likelihood is a pixel-based classification. So and random forest we can use for both classification and regression problem. So this classification we have implemented doing supervised classification. SVM is one which we have implemented in our lab to find out the land use classes. So we have got good result with SVM. And coming to regression, here we have like okay, classification, we can say that we have to give a segmented image for supervised classification. So here the segmentation reduces, means it gives what they say workflow. It reduces the work of an algorithm to do. If you go with the ArcGIS, if you have seen, if you give the segmented image, the processing of that data is it takes lesser time because it is already segmented and it gives more accurate result. And when we, sorry. Okay, coming to regression, we have Naive Bayes and KNN. So here we have Naive Bayes algorithm. It is mainly a statistical model which we used, and it gives more accurate result when compared to KNN or any other classification. So, and Naive Bayes, we can say that we use it in other applications like email spam thing and all to find out these things. So that is also one of the application apart from spatial thing. And KNN, we have nearest neighborhood, which is non-parametric lazy learning algorithm. We can say this is it doesn't assume more with the data distribution. It doesn't require more data training techniques for this. So coming to unsupervised classification, we have clustering. So clustering, it is a important data mining technique which is widely used for remote sensing data. And we have some of the analysis like density clustering, and we have hot spot creation, cold spots creation, then spatial outliers, similar zones. So we have all these pattern recognition algorithms here in the clustering. And okay. Coming to PCA, it is like a principal component tool which is used to remove the redundancy. So mainly to do the redundancy. In spatial application, it is applied on the band layer, which is like there are several bands will be there, and whichever band you want to which is not required. Suppose if it is like Landsat image or any other image, you can apply PCA for a dimensionality reduction and do your analysis. So coming to some of the examples which we have worked in, this is PADI identification process. So once we download the data, we Sir is there, Shiv Mohan sir. He has guided us through this process. So he will be taking the SAR data session next time, his session. So he'll be explaining it in detail. I'll just go through what we have done. That after data download, we have a data processing thing which is in a Snap software, which is a freely available software for which is available in Sentinel Hub, and we do pre-processing things here like calibration, speckle filtering, geometrical corrections. So these things we will do, and whatever final image output we have is two polarized data we have, VV and VH. And we extract backscatter value using ArcGIS. So we, after getting that image output, we'll take a backscatter value for each plots. So we have as Deepak sir earlier spoke about our farmer advisory and other things. So we are giving advisory based on a plot, farmer plot. So with respect to a plot, we are taking a backscatter value. So it is pertaining to only to his plot, and that value, backscatter value, has been put to our SQL Server stored procedure algorithm. We are not using right now any deep learning techniques. Maybe next we are going to use that. But right now, what we have done is we are giving that extracted zonal statistics into a stored procedure where we do a time series analysis. So here we are identifying which are the PADI plots which is like 4 to 5 weeks, within 4 to 5 weeks, or like up to 1 month or something like that, we'll know the signature of the paddy. So paddy signature is like when it starts with the water content in it. So water content is minus 18 decibels in which is the starting point, and it raises, the curve raises, and again it comes back. So that is a logic we have, and once that started, so that is our point to find a paddy plots. So first we'll see, and with multiple images, multitemporal images, we'll find we'll do a analysis of how the curve is raising. So there, from 2 to 3 images, we'll find out, so which are the paddy plots there, and which are actually a water body. Maybe it may be a water body inside, or it may be any other plots which is there. So we'll find out whether 3-4 weeks, and after that we'll get a rising curve, and it will come down after that. So that is our logic behind this, and we'll be able to plot all the paddy in our area. So this all green color, we don't have feature class for all these things, all cadastral layers. We had cadastral layers only for this. All green plots are paddy plots, which has been identified. So this is water body mapping, which is done for the Rabi season. So Rabi season, we can see that the trend, how it is increasing and decreasing. So in here in January and February, we have a good monsoon rain, and in March, April, and June, it is decreasing. From July onwards, it is increasing. We did with this for multispectral data. For SAR data, actually we did not do, because the count thing, the data we had a Sentinel-1, and it had 5 by 20 meter resolution. So maybe this was giving, we had to give it to the government people there working OUAT and all. So the count thing, we thought that, okay, they may find it that there is a discrepancy in what you are telling and this thing. So only we did it for multispectral data. So this is comparison between February 19, 18, and 17 data. You can see that this water body in 17 and 18, it did not, like it was not there. Water body did not exist. Maybe it was, I don't know what had happened. And in 2019, it was seen in our image. And here, this is how to distinguish between a perennial and Rabi crop. So if you see here, the plots which are in yellow color, we can see that there is a disappearance of vegetation, which is in redness. So after January onwards, so there is an increase. So from Kharif to Rabi, there is a transition. So we could find out these are the Rabi plots, and if you see here, these plantation plots, these are perennial. So we had a plantation thing which is continuously, which is going for all over year. So this is considered as a perennial crop, and here Rabi crop. So we did a ground truthing of what we have, we were mapping, just to find out how accurate we were. So we did it for a June image, which was taken, and water body things, it was like 100% matching. And for the fallow land, it was accurately we could do that. Most, it is 95% precision is there. Cropland and fallow land, actually there was a transition at that time. So it is June to July, they are doing the Kharif thing. So that we could find out some of the plots which was identified as a cropland, there was going it into a plantation also, and few into fallow land. So we recorrected our algorithm to do that, and this is how we plotted this. So, and coming to R packages for spatial data. So these are some of the R packages. I would say this is given by Giri sir. So, so more details here, you can go through this. So it is like available in the GitHub thing. So this I will not show, maybe it is, I don't have time. So this is for, first few are for mapping purpose, and this auto image is for visualization purpose. So this we can use with the R package, and this is one example which we did for row detection. This is coconut tree. We had an image of coconut tree, and we're using R package, we did a row detection. And future of image analytics, if you have to say what is, where is future of image analytics heading, we can say that previous talks also you might have heard that it is like citizen image, that crowdsourcing images are now coming up, and now things needs to be automated. So all things whichever is manual now, it should be automated, and bulk processing. So it reduces our effort, and it should be simple and plain things to be done. So this is one face detection algorithm which is available freely in internet. This is one interesting thing. I'll just take 2 minutes just to show. So it is showing two faces are different people here. So it is showing the confidence level. And if I have to put one more image, so it is given by Azure. So now two faces belong to same people, confidence level. So it is open source available. You can do this analysis, and it detects the face and emotion detection, and you can here. So it is detecting the face. So this is my daughter, and this is my mother. So I thought I would take this as an example because they help me a lot in doing all these things, running around and all. So with this, I'll stop, and Praveena will show you what are available website, which is GIS Ready Data, which is already available, and you can do a few of the analysis there only. Over to you, Praveena.
I'm going to explain how to download the data from different sites. This is one of the site from USGS. Here we can download the different kinds of data. So there are so many data sets available in this websites. You can just go through data sets. There are aerial images and UAVs, Landsat, NASA products, and Sentinel. All those products are available. Now just I'm going to show some example. It select geocoding method or else path or row, what is the convenient method for you. I know path and row for my area. I'll just select path and row. My path is like a 141. Row is like a 46. It will show the location of that path and row. And I'll go to data sets and Landsat collections. Landsat collection level 1. There are products are there. I'm just downloading the Landsat 8 data and submit the results. You will get all the results. You can see the latest image of Sentinel Landsat 8 image, 22nd Jan. You can click on the image. You can preview the image, but you can't do any analysis here. Just you can go to download option. The level 1 GeoTIFF data product. You can click on this. You can get all the bands of this image. It will take, one image, it will take 800 MB data. I just clicked on, it started downloading. I'm going to show there are so many data sets available. Here you can see Sentinel also, but sometimes Sentinel data, it won't update in up to date. For Sentinel, they have their own site for SkyHub Copernicus. I'm just going to show that. This is the Skype Copernicus site. This is sponsored by European Space Agency. Here also, like here, you will get all Sentinel products. What are the open source are available? I'm just going to first. I'm going to here. There is no area of interest. Upload the option. We have to just select the area by manual selection. We are in Bangalore. I want to just select area for Bangalore. Sorting date by sensing date, order by ascending order, sensing period from Jan 1st to today's date, Sentinel 1, product type, GRD, Sentinel 2, L1C classification, I'm just search. This is the SAR image. It's like a 2020 and first 2020 and January 1st image. These all are the images. We're just going to see what is the latest image here. Is the 24th January is the latest image of Bangalore. You can see here date is looking here. You can see date here. Just you can click on the download. But in this site you can download parallelly. Only 2 images only you can download parallel time. If you want to click third image, this site it won't allow to download third image. And I'm going to show that is one more website called Land Viewer. It's very most interesting website for me. Who are working on satellite images, open source. We no need to work on like sometimes we need analysis ready data immediately. There you can just go and click on Bangalore. Just you can select, and you can select the satellite images. I want passive sensors, and date I'll select from January 1st. Today is the January 29th. And I want Sentinel L1C data. Remaining I don't want. There are so many data are open source data are available in these sites. Here also it will come 24 Jan is the latest date of image. After clicking this image, sometimes I want to do analysis on fly only. I no need to work on like some software ArcGIS, QGIS. Here your on fly process, you can do some analysis of band combinations. You can click on that image. You can see natural color combination and color infrared. It will process on fly. You can see the results on immediately here only. There are different combinations like there are 20, 30 band combinations are available here. Whatever combinations we want, we can see it. I just want to see NDVI classification here. If I want to see like NDVI analysis for last 1 month, there is a one time series analysis option. You just click on time series analysis. Here NDVI. Sensors, I am selecting Sentinel-2, period of 1 month. Apply. You can see the curve from last 1 month. We have taken data from last 1 month, how NDVI has changed. That blue-white curve is like showing the mean value of NDVI for last, how many images are, 6 images are there, 6 images is showing on NDVI curve. If you want to download this data, I can download. If anything, we can do it and we can save to our system. This Excel will open and you can show all the details. These the values it will show like a date wise and what is the mean value, average value, maximum value. Cancel. I'm going to cancel. Here there are so many other options also there, like a change detection analysis and clustering analysis. You can do it on fly in these websites. If you want to store this image, you can store it on their cloud also. You can download to your system also. I'm just going to show how to download the image here. Just go to download. But here if you want to download image, you can download only low resolution image. If you want to high resolution, you have to pay for that, you have to subscribe for that image. It's downloading the image, it will take some time to download. This is the image we have selected, downloaded. And there is one more site like same thing like this, like a Sentinel Hub. It's also like same process what I have shown in like Land Viewer. But here we can download the images like unlimited like way. But Land Viewer, if you want to download more images, it will ask subscription for that images. But here you can download all images. It shows the same like a calculations of indexing analysis here also. But here one option is very interesting. You can do the animation on this site. If you have like multiple images, I have like NDVI images are there. Like images I want to same place, I want to create animation like a GIF. You can do it on this site and you can download your system. And just I'm going to show that. This is the same time, what is the Sentinel, what is the satellite we want and date range. These all are the clouds. Actually, I didn't select the area. I'll just Bangalore. Visualize. Same thing as shown in we have Land Viewer also, same thing is here also we can see. Here I want to create a small animation. I will just select the images, same place. You can see simply you can download, we can whenever we want to we can create in like within minutes without time. Same like this we can create NDVI analysis, what are the indexing analysis available. And again if you sometimes we want like our own custom indexes, we can create that custom index also. There are bands are there, you have to just drag and drop and you can click your own band indexes also can available. And this place you can download the images like with georeferenced image, but resolution is like a little bit less. But you can georeferenced, you can take to the QGIS, ArcGIS, anything you can process. You can take it like if you want to map out, you can keep it as a map. And one more thing I want to show about like a remote pixel. It's very interesting, whatever we have shown like a Land Viewer or else Sentinel Hub, anything if you want to download the data, you have to give the user ID and password. In these websites, you no need to give any user ID and passwords. You have to just go to their website. You can select the path or row. One minute. We have to just go to their site and we have to just search the style or like a path or row and just click on that, it will automatically download. It won't ask any password or anything. It will automatically click on that link, it will download to our system. These all are the open source satellites available on websites. I hope it will be useful for you, all of you. Thank you.